Good evening to all. In this video, let us discuss some basics of signals. First, let me know about signal. What is meant by signal? A signal is an information which is given to the system. Okay. So here we know this is system. Input signal may be represented by x of t and output signal may be represented by y of t. Input, output. System is the interconnection of elements. This system processes the input signal and it gives the processed input as output. That is represented by y of t. This we know. This signal is a single valued function. Single valued function, and it is dependent on the various variables. It may be classified as one-dimensional signal, two-dimensional signal, three-dimensional signal. If it is a one-dimensional signal, we can represent signal as f of x. If it is a two-dimensional signal, it is dependent on two variables. Okay, so we can term this as f of x comma y, where x, y are the dependent variables. Now y is a function of the signal, and three-dimensional means it is dependent on three variables x, y, z. Okay, so this is a single valued function. This is a signal representation, basic signal representation. And now let me discuss some basic operations on signals. First let me discuss the representation of continuous time and discrete time signals. First, classification. So here, classification of signals. We can classify the signal as a function of time, on the basis of function of time, as continuous time signal and discrete time signal on the basis of function of time. Okay, continuous time signal is a signal. It varies. It will be noted for all time. It is defined for all time instance. It is defined for all time instance. And this discrete time signal, it will be defined at the specific intervals of time. So this is the difference between continuous time and discrete time signal. Now let us discuss some representation of continuous time and discrete time signals. Representation of CT and DT signals. Normally, what are the types of signals? First one is step signal, and second one is impulse. Third, ramp. Okay, so let me study the representation for the step signal for both continuous time and discrete time signal. So step signal can be represented as x of t equal to u of t. Okay, x of t equal to u of t, where u of t equal to a for t greater than or equal to 0. Equal to 0 otherwise for t less than 0. Okay, so this is a step signal. U of t can be represented as here it is represented as a. That means the curve will be, the amplitude will be a for all time when t greater than or equal to 0. Equal to 0, the function equal to 0 otherwise. Okay, so this is x of t. U of t, unit step signal means unit step signal that can be represented as u of t. So u of t equal to 1, u of t equal to 1 for t greater than or equal to 0. Equal to 0 for t less than 0. So it will be represented as This is amplitude is 1, representation of unit step signal. T equal to, that is u of t equal to 1 for all time that is greater than or equal to 0, time greater than or equal to 0, or equal to 0 otherwise for t less than 0. In the negative side it will be 0. This is the unit step signal representation. This is a continuous time signal. If it is specified at specific intervals, if it is defined at specific intervals of time, so this is for CT signal. And for DT signal, we can represent this sequence as u of n, unit step sequence or unit step signal, that is equal to 1 for n equal to n greater than or equal to 0. That means n equal to 0, 1, 2 like that. Okay. So here 0 for n less than 0. So we can draw the curve like this. That means u of n equal to 1 at the specific intervals of time. All the values, for 0 index also the value is 1, and for 1 time index also with respect to n. Okay, 1 for 1 also the amplitude is 1, and for 2 also second time period also the amplitude is 1, third, fourth, for all the time it is, the value is 1. So this is the representation for the DT signal for unit step signal. Okay, and let us discuss impulse signal. So what is the representation of impulse signal? X of t equal to del of t. Okay, so that is equal to 1 for t equal to 0. At the origin only the value equal to 1 or a. Normal impulse means it can be represented as a. Unit impulse signal means it will be, the value will be equal to 1. Okay, equal to 0 for t not equal to 0. So the representation is, this is a 0 time index, del of t with respect to t, unit impulse signal. So unit impulse signal, it is equal to 1. If it is a normal impulse signal means the value may be anything that is that can be represented by a. Okay, at t equal to 0. For the time origin, for the origin time only the value will be there. Otherwise in the negative side also and in the positive side also, for t less than 0 also, for t greater than 0 also, the value will be equal to 0 only. Okay, del of t equal to 1 for t equal to 0, 0 for t not equal to 0. This is the signal representation, equation representation for impulse signal. Unit impulse signal is 1, represented by 1 for t equal to 0. Normal impulse signal will be represented by a for t equal to 0. So this is CT signal. And let me consider DT signal, discrete time signal. So discrete time signal also same thing only with respect to n. So at the origin time only the value will be equal to 1. So it will be represented by del of n, unit impulse sequence. Okay, and then ramp signal. Okay, so this is a linear, it's like a linear signal. So here we can represent CT signal, x of t equal to t. Okay, x of t equal to t for t greater than or equal to 0, equal to 0 for t less than 0. Okay, so the representation of waveform is with respect to t. This is x of t equal to t. It is like the line, because y equal to mx plus c. So here t, the slope is 1. Okay, the slope is 1. X by y is, y by x is 1. Okay, so x of t equal to t for t greater than or equal to 0. So here the input is increasing linearly with respect to time. Okay, so we can define the slope from the equation. So in the DT signal, discrete time signal, it will be defined at specific intervals of time. So consider this as n, this as x of n, that is equal to n, means for 0 time index, this is 1, 2, 3. The value will be increasing linearly, so increasing at the specified intervals of time. So it can be represented like this. Okay, 1, 2, 3, like that. For x of 0 equal to 0, x of 1 equal to 1, x of 2 equal to 2, x of 3 equal to 3, like that. So the amplitudes will be represented for the ramp signal like this. Okay, so this is the 3 representation, and then fourth one is exponential signal. So exponential signal, that can be represented as x of t equal to e power 8 for t greater than or equal to 0 and equal to 0 for t less than 0. So exponential signal we know. So this is a increasing exponential x of t, and if it is e power minus at as signal means that is a decaying exponential. The curve will be like this. Okay, so this is a representation for a exponential signal. So for a discrete time signal, it will be represented by, it will be defined at the specific intervals of time, like this. Okay, so this is the exponential signal, and last one is sinusoidal signal, that we know. Fifth one is sinusoidal signal. Sinusoidal signal. So x of t equal to, that can be represented as a sin omega t for t greater than or equal to 0. 0 for t less than 0 means the curve will be like this, sinusoidal waveform. Okay. The amplitude is A, represented by here. So this is in the case of CT signal. In the case of discrete time signal, it will be specified at the specific intervals of time, like this. So we can represent, this is with respect to t, with respect to n, x of n equal to a sin omega n, that can be represented as this is a discrete time signal for the sinusoidal. Okay, so these are the representation of continuous time and discrete